This is the screencast for section 9.4, example 5. You've seen both infinite sequences and finite sequences defined explicitly and recursively. Well, now there are two different ways that each term can be related to each other in a sequence. There are arithmetic sequences, which we'll learn about in this example, and then geometric sequences, which you will learn about in example 6. Arithmetic sequences all have a common difference. So the first term is a, the second term is a plus that difference, the third term is a plus then twice that difference, etc. So you end up with somewhere in the sequence a plus the number of term minus 1 times that difference, which is kind of an explicit definition. Recursively, the sequence would be defined as the previous term plus that difference for any term after second term or later. In example 5, we're going to find the common difference, the nth term, a recursive rule for the nth term, and an explicit rule for the nth term for these two sequences. So number 1, I first need to find the difference. So I'm going to take the second term minus the first term to find the difference, and that will be a difference of 4. Next, I need to find the 10th term. So that will be defined as the first term plus 9 differences, or 9 fours. And we are increasing by 4, so that would be a positive 4. So 36 minus 6 is 30. A recursive rule for the nth term then would be the previous term plus the difference, 4. An explicit rule for this sequence, arithmetic sequence, would be a sub n equals the first term in the sequence plus n minus 1 of the differences. So I could simplify that to be 4n minus 10. Now in number 2, we got to work with logs. So to find the difference, we'll take the second term, natural log of 6, and subtract the first term, natural log of 3. And by a log property, that would be the natural log of 6 over 3, which is the natural log of 2. So the difference is the natural log of 2. My 10th term then would be my first term, natural log of 3, plus 9 natural log of 2's, which then by another log property could be the natural log of 2 to the 9th, and then the natural log of 3 times 2 to the 9th, which is in total the natural log of 1,536. Part C, a recursive rule for this series would be taking the term before the nth term, so a sub n minus 1, and adding the difference, natural log of 2. An explicit rule would be using the first term and adding n minus 1 differences. Now because this is a coefficient of natural log of 2, I can also make that an exponent, so that could also be written as the natural log of 3 plus the natural log of 2 to the n minus 1, which then can be simplified to the natural log of 3 times 2 to the n minus 1. The now try problem number 21 asks us to find all the same stuff we did in the example for this arithmetically defined sequence. So the common difference here is 10 minus 6, which is 4. The 10th term would be 6 plus then 9 fours, so 36 plus 6 is 42. A recursive rule for this sequence would be the term before it plus 4, and an explicit rule for the nth term would be the first term plus n minus 1 fours, which simplifies to be 4n plus 2.